We're working in section 2.3. We're talking about functions. We've already had the definition of a relation and a function, and we've seen some examples. We've also been talking about domain and range, and we're going to talk about them some more. And then this third topic, determine whether a graph or an equation represents a function. We covered this pretty well in the previous video. So now in this video, here in example 4, we're looking at some equations, but notice we're already told that each of these is a function. So we don't have to determine if it's a function or not. We just need to find the domain and the range. Let's look at this first example, y equals 2x plus 1. This is a linear function, similar to the linear equations that we solved in chapter 1. Notice we just have x to the first power. So a linear function. If we want the domain, we're asking what are all the possible x values? Well, let's think about it. What do we need to do with that x value? We need to double it, and then we need to add 1. Can't you do that with any real number? You can multiply by 2 and then add 1 for any real number. So any real number fits the domain. The domain is all real numbers. And we're going to write that in interval notation as negative infinity to infinity. And similarly, if you think about plugging in a large positive value for x, you can get large positive values for y. If you plugged in a large negative number, I don't know, negative 1,000 or negative 1,000,000. If you plugged in negative 1,000,000, then wouldn't you get approximately negative 2,000,000 for your y value? So your y values will go from negative infinity to infinity as well. And for this example in particular, it might be nice if we could think about the graph of that function. The graph looks about like this. The y-intercept is 1. There's an x-axis and a y-axis. We'll talk more about graphing linear functions in the next section. But for now, maybe the graph helps us to feel good about this domain and range. Okay, let's go on to number 2. This is something we've seen before. This is absolute value. So we studied absolute value equations in chapter 1, and now we're going to find the domain and range for this absolute value function. So the domain is, again, what are the possible x values? Well, what are you going to do with that x value? You're going to subtract 2. You can do that for any real number. And then you're going to take the absolute value of that real number. And of course, you can do that with any real number. So once again, domain is all real numbers. Now, there's an interesting thing that happens. It doesn't matter what you have inside the absolute value. Inside the absolute value could be any number, large or small, positive or negative. But once you take the absolute value of that, then the result is a positive number or 0. And so the result is the y value, is the range, is the set of positive numbers and 0. And so there we have it. It's a similar idea for the range in number 3. When you take the square root, you always get a positive number. And so the range here would be 0 to infinity. But the domain is not all real numbers this time. Let's see here. If you're going to take the square root of a number, and again, we're only talking about the set of real numbers, right? We want our output to be a real number. Then x minus 2 must be greater than or equal to 0. So here is an example where we can write a little equation. X minus 2 must be greater or equal to 0. and then we can solve that. And so when we solve it, we add 2 to both sides, and we say x is greater or equal to 2. I made a little mistake there. X is greater or equal to 2. And so the domain is from 2 to infinity. If we put in a number that's less than 2, then the y value is not a real number anymore. Okay, let's go on to the last one. Again, there's a restriction on the domain. This time we have a rational function. Remember, we studied rational equations in chapter 1. So here's a rational function. Now you know the denominator can't be 0. So if the denominator is 0, then there is no y value. Then there is no output. That's undefined. So what we're going to say here for our domain is that x minus 2 is not equal to 0, or x is not equal to 2. X could be any other number besides 2. So how do we write that in interval notation? We start from negative infinity and we go all the way up to 2. We use parentheses to say that we're excluding 2. And then we continue on the other side of 2 all the way out to positive infinity. So there's our domain. And then the range is just a little bit tricky here. There's one number that's not possible for y. So can you see what it is? Y in this particular equation, y is not equal to 0 ever, regardless of what you put in for x. And the reason is that you have a fraction here. The only way for the fraction to be equal to 0 is if the numerator is 0. This numerator is never 0 because it's always 1. And so when we write the range, we're going to have to write all real numbers except for 0. It might be nice to write that out in words. You know, we've just used interval notation here to say all real numbers except for 0. All real numbers except for 0. So it's important to connect that statement with this notation. Similarly for the domain, all real numbers except for 2. Okay, that's all for now. We'll pick up in the next video.